3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond.
Good evening. In mid-July, we witnessed two truly historic events. Not only has NASA succeeded in sending a robotic spacecraft to every planet in our solar system, the space probe New Horizons has successfully swept past Pluto and revealed the planet's surface detail for the very first time. Let us just remind ourselves about the New Horizons spacecraft. It is the size and shape of a grand piano with a main communications dish attached to the front. It weighs 478 kilograms, which is about 1,000 pounds. The probe was launched from Cape Canaveral on the 19th of January 2006 on a 9.5-year journey to the edge of our solar system, coasting along at an average speed of 9,000 miles an hour. The craft bypassed Jupiter in February 2007, which gave it a gravitational slingshot to increase its speed, and New Horizons arrived at Pluto in July 2015. This summer, we made a program all about New Horizons and the discovery of Pluto. Pluto, Planet of Mystery, is available to watch again on our Vimeo website. New Horizons successfully made a close approach to Pluto and its moons on the 14th of July and has just begun the task of returning all of its historic images and science data to waiting scientists, a process which will take a year to complete. So now is a good time to look at the images we have received so far. New Horizons has 6 science instruments on board, including the Long-Range Reconnaissance Imager, LORRI, which is designed for high-resolution photography at visible wavelengths. The instrument is equipped with a 1024 by 1024 pixel black and white camera with an 8-inch that's a 20 centimeter aperture lens. This is Pluto, the last planet to be discovered at the edge of our solar system, as imaged by New Horizons 3 months ago. We now know that Pluto is a very cold and strange world, with ice mountain ranges almost 2 miles high, huge glaciers, craters, rills, along with a vast atmosphere extending almost as far as 6,400 miles. About 4.5 times the diameter of Pluto. That's more than halfway to Pluto's largest moon, Charon. So far, only a small number of images have been released by NASA showing Pluto and its moons, yet they have proved to be fascinating and are making planetary scientists think about how elements behave and flow at super cold temperatures. Pluto is slightly more than 4.6 billion miles from the Earth, so the sun's light and heat is feeble. The average surface temperature on Pluto is minus 243 degrees centigrade, so that it is not only water that turns to ice, methane and nitrogen do so too. In the vacuum of space, nitrogen turns to solid at a temperature of minus 210 degrees centigrade. Before we move on to see the detailed images of Pluto's surface, we need a map of the landscape to find our way around. NASA scientists have now named a number of informal features on Pluto after interplanetary spacecraft. These will have to be agreed by the International Astronomical Union, the governing body responsible for naming craters and surface features on objects in the solar system, before they become permanent. However, they are a useful guide. The largest area on Pluto, a heart-shaped region, has been named after Clyde Tombaugh, who discovered Pluto in 1930. Here is a NASA surface map of Pluto with the informal names in place. The large heart-shaped feature has been named Tombaugh Regio, with Voyager Terra and Pioneer Terra above. On the right of the heart feature is Hayabusa Terra and Tartarus Dorsa. Hayabusa in Japanese literally means peregrine falcon. It was the name given to the first Japanese space probe to return a sample of material from the asteroid Itokawa 5 years ago. In Greek mythology, Tartarus is both a goddess and a place in the underworld. In ancient Greek mythology, Tartarus is as far below Hades as the earth is below the heavens, and is a place where souls were judged after death and where the wicked received divine punishment. As we rotate the globe, Viking Terra comes into view, with Venera Terra above, along with the huge crater on the surface of Pluto that has been named Burnley. Lowell Regio is on the left, which has been named after the American astronomer Percival Lowell. Another rotation of the globe, and we come to a series of linear grooves on Pluto that have been provisionally named Lunar Linear, Turanian Linear, and the double surface feature has been named U2 Linear. Chandrayaan-1 was India's first lunar probe, and U2 appears to be a reference to the Chinese lunar rover which landed on the moon in January 2014 during the Change 3 space mission. I made a program all about this at the time. In Chinese, U2 literally means jade rabbit. Measurements by New Horizons as it travelled past Pluto indicate that the diameter of the dwarf planet is 1,473 miles, thus about 53 miles bigger than previous estimates. In this graphic, we compared the size of Pluto with that of the Earth-Moon system and the planet Mercury. Straight away, you can see just how small the planet is. Principal scientist Alan Stern said this means that Pluto has a lower density than thought, which could mean an icier and less rocky interior. This adds to growing evidence that Pluto may have a liquid ocean or ice mantle below its surface. Until recently, astronomers estimated the density of Pluto to be 2,030 kilograms per square meter, which is twice that of water. If this was correct, it would mean that there is a greater percentage of rock and less of ice than in the satellites of the giant planets, in the ratio of 70% rock and 30% ice. The new findings from New Horizons means that Pluto's density has dropped to 1,879 kilograms per square meter, which means that most of the rock on Pluto has a density between 2 to 3,000 kilograms per square meter, and ice at very low temperatures has a density of 927 kilograms per square meter. So we now know that Pluto is composed of about 65% rock and 35% ice. Because the decay of radioactive elements would eventually heat the ices enough for the rock to separate them, scientists expect Pluto's internal structure to be differentiated, with the rocky material having settled onto a dense core surrounded by a mantle of water ice. In round figures, the diameter of the core is thought to be over 1,000 miles, and the crust is believed to be less than 290 miles in thickness. According to scientists at the Johns Hopkins Applied Physics Laboratory, there is an intriguing possibility that an ocean of liquid water underlies Pluto's icy shell up to 110 miles deep. The ocean may be mixed with or overlie an organic rich layer, there is evidence that the icy moons of Jupiter and Saturn have hidden oceans, and our improved understanding of heat generation and transport in icy whales make this a real possibility for Pluto. Life, as we know it, requires three things: water, biogenic elements, that's elements to build life, a source of energy, light and heat that a living organism can use, time for life to start, and sufficient environmental stability for it to evolve and carry on growing. Pluto's surface is far too cold for liquid water, but its interior is probably warm and maintained that way by the slow decay of naturally occurring elements such as uranium, potassium-40 and thorium. Enough heat is released that a water ocean may exist between the rocky core of Pluto and its thick outer layer of ice. Pluto's ocean is also likely to contain biogenic elements in a solution, especially if it is in contact with an organic, rich surface layer. Pluto's ocean would be dark and cold, near freezing. If it is in contact with a rocky core, it is likely that this modest core is today insufficiently hot to be volcanically active or even to drive hydrothermal vents. So it is difficult to argue for a deep biosphere on Pluto today. On the other hand, it is also true that Pluto's rocky core was much hotter and probably more active in the past. So it is not unreasonable to speculate that some form of primitive microbial life may have evolved long ago. Besides the revised size of Pluto, scientists have also confirmed that Pluto's North Pole is indeed icy, as had been suspected. It's packed with methane and nitrogen ice. The New Horizons mission also found in LORRI images evidence of unusual ices flowing across Pluto's surface, revealing signs of recent geologic activity, something scientists hoped to find but didn't expect. The temperature on Pluto is minus 243 degrees centigrade, which means that these ices can flow like a glacier, said Bill McKinnon, deputy leader of the New Horizons Geology, Geophysics and Imaging team. Peering close at the heart of Pluto, in the western half of what mission scientists have informally named Tombaugh region, New Horizons' Ralph instrument revealed evidence of carbon monoxide ice. The contours indicate that the concentration of frozen carbon monoxide increases towards the center of the region. The science team also unveiled photos showing 11,000-foot mountain ranges on Pluto, similar to the Rockies here on Earth. The peaks are now known as the Norgay Montes. Tanzeg Norgay was the Sherpa guide for Sir Edmund Hillary when they conquered Mount Everest in 1953. The new images show fascinating detail within the Texas-sized plain informally named Sputnik Planium, which lies within the western half of Pluto's heart-shaped feature known as Tombaugh Regio. There, a sheet of ice clearly appears to have flowed, and may still be flowing in a manner similar to glaciers here on Earth. Additionally, new data from New Horizons' Ralph instrument indicate that the center of Sputnik Planium is rich in nitrogen, carbon monoxide and methane ices. The plains look to be relatively young, about 100 million years old, and scientists speculate that internal heating, perhaps from icy volcanoes or geysers, might still be shaping these crater-free regions. However, at the moment, scientists have no hard evidence of erupting geyser-like plumes on Pluto. Another possibility could be that the terrain, like frozen mud cracks on Earth, formed as a result of contraction of the surface. The plains, which include clusters of smooth hills and fields of small pits, are covered with irregular shaped or polygons. sections that look to be separated by troughs. Each section is roughly 12 miles across. The height of the hills is not yet known, nor their origin. It could be the hills were pushed up from below, or are mounds surrounded by eroded terrain. The fields of pits resemble glacial fields here on Earth. In the southernmost region of the heart, adjacent to the dark equatorial region, it appears that the ancient, heavily cratered terrain has been invaded by much newer icy deposits. As the New Horizons spacecraft closed in on Pluto, it detected traces of Pluto's nitrogen-rich atmosphere further from the dwarf planet than anticipated. As I said earlier, Pluto's atmosphere may extend to 6,400 miles. Pluto has a thin atmosphere consisting of nitrogen, methane and carbon monoxide, which are in equilibrium with their ices on Pluto's surface. The surface pressure is roughly 1 million to 100,000 times less than Earth's atmospheric pressure. The presence of methane, a powerful greenhouse gas in Pluto's atmosphere, creates a temperature inversion, so average temperatures are warmer 6 miles above the surface. The lower atmosphere contains a higher concentration of methane than its upper atmosphere. Pluto's elliptical orbit is predicted to have a major effect on its atmosphere. As Pluto moves away from the Sun, its atmosphere should gradually freeze out. When Pluto is closer to the Sun, the temperature of Pluto's solid icy surface increases, causing the ices to sublimate. That is to say, turn directly from a solid into a gas without passing through the liquid phase. This has now been confirmed by New Horizons. The science instruments have detected a change in the density of Pluto's atmosphere, which is less than that measured back in 2006 when the spacecraft was launched on its way. 7 hours after closest approach, New Horizons aimed its long-range reconnaissance imager, LORRI, back at Pluto, capturing sunlight streaming through the atmosphere and revealing hazes as high as 80 miles above Pluto's surface. A preliminary analysis of the images showed two distinct layers of haze, one about 50 miles above the surface and the other at an altitude of about 30 miles. The hazes detected in these images are a key element in creating the complex hydrocarbon compounds that give Pluto's surface its brown and reddish colours. Models suggest the hazes form when ultraviolet sunlight breaks up methane gas particles, a simple hydrocarbon in Pluto's atmosphere. The breakdown of methane triggers the buildup of more complex hydrocarbon gases, such as ethylene and acetylene, which were discovered in Pluto's atmosphere by New Horizons. As these hydrocarbons fall to the lower, colder parts of the atmosphere, they condense into ice crystals that create hazes. Ultraviolet sunlight chemically converts these hazes into thiolins, the dark hydrocarbons that colour Pluto. The term thiolin was first used by astronomer Carl Sagan and his colleague Vaishon Korea to describe the difficult-to-characterize substances he obtained in his experiments on the gas mixtures that are found in Titan's atmosphere. Titan is the largest moon of the lovely ringed planet Saturn. Scientists had previously calculated that temperatures would be too warm for hazes to form at altitudes higher than 20 miles above Pluto's surface. Pluto's atmosphere is continuously being replenished, and this nitrogen has to come from somewhere to resupply both the nitrogen ice that is moving around Pluto's surface in seasonal cycles and the nitrogen that is escaping off the top of the atmosphere as a result of heating by ultraviolet light from the sun. Planetary scientists, including principal investigator Alan Stern of Southwest Research Institute, looked at a number of different ways that nitrogen might be resupplied. Stern wondered if comets could deliver enough nitrogen to Pluto's surface to resupply what is escaping its atmosphere. They also looked at whether craters made by comets hitting the surface could excavate enough nitrogen, but that would require a very deep layer of nitrogen ice at the surface, which is not proven. The team also studied whether craters could expose more surface area by punching through the surface deposits that would likely have built up over time. Alan Stern and his team have come to the conclusion that all of these effects, which are the major ones from cratering, do not seem to provide enough nitrogen to resupply the escaping atmosphere over time. While it's possible that the escape rate was not as high in the past as it is now, the science team think that geologic activity is helping by bringing nitrogen up from Pluto's interior. Turning now to Pluto's retinue of 5 known moons, despite expectations, New Horizons scientists have not discovered any more in the images sent back from the spacecraft so far. The largest moon is Charon, which has a diameter of 1,208 kilometers, 751 miles, and is just over half the size of Pluto. Like the Earth moon system, Charon and Pluto may be classed as a double planet, and Charon is locked in synchronous rotation so that to an observer on Pluto, the moon always keeps the same hemisphere on show. From this single image of Charon, taken by New Horizons, which is all we have at the moment, we can see canyons that look to be 3 miles to 6 miles deep and are part of a cluster of troughs and cliffs stretching 600 miles, or about twice the length of the Grand Canyon here on Earth. In 2007, Observations by the Gemini Observatory of patches of ammonia hydrates and water crystals on the surface of Charon suggested the presence of active ice geysers and ice volcanoes. Charon's volume and mass allow calculation of its density, from which it can be determined that Charon is slightly less dense than Pluto and therefore contains a larger proportion of ice relative to the rock in its interior. So far, we only have one high-resolution view of Charon and distant close-up views of Pluto's other two moons, Nix and Hydra. Pluto's moon Nix, shown here on the left in enhanced colour as imaged by NASA's New Horizons RELF instrument. It has a pinkish spot that has attracted the interest of mission scientists, which is a huge crater. At the time the observations were taken, New Horizons was about 102,000 miles from Nix. The image shows features as small as 2 miles across on the moon, which is estimated to be 26 miles long and 22 miles wide. Pluto's small, irregular-shaped moon, Hydra, is shown on the right in this black and white image, which was taken by New Horizons on July 14, 2015, from a distance of about 143,000 miles. Features as small as 0.7 miles are visible on Hydra, which is 34 miles in diameter. We will now have to wait until more images and science information is transmitted back to scientists to be able to determine the true nature of the surface features on the moons of Pluto. This process is now accelerated, so we will get to see many more images in the weeks ahead. Please bear in mind that Pluto lies at the edge of our solar system, and it takes more than 4 hours for information to be transmitted back to Earth, and remember too that New Horizons is speeding away from us at over 4 kilometers a second, so this time period is increasing. The naming of surface features on Charon is an art in itself. Like Pluto, NASA has provisionally named a number of large surface features, and this time planetary scientists look towards science fiction for their inspiration. I am most grateful to Maureen Gaday de la Cruz, who is a lawyer living in the Philippines, and Tony Doubtfire of Leeds here in the UK, for helping me to interpret the named features on Charon. Maureen told me that it is really cool that they've chosen all of these names. Science and science fiction have mutually inspired and promoted each other. A NASA ship has been named after the starship Enterprise in Star Trek, after all, she said. The names include characters from the TV series Star Trek, Star Wars and Doctor Who. So look out for Kirk Crater, Spock Crater, Sulu Crater, Yuzora Crater and Vulcan Planium. As a salute to Star Wars, we have Skywalker Crater, Leia Organa Crater and Vadar Crater. And for good measure, there is TARDIS Chasma, which appears to be a reference to Doctor Who's time machine, and Gallifrey Macula. Gallifrey is the homeworld of Doctor Who and the Time Lords. In addition, there is Kubrick Mons and Clark Crater, which is a salute to the film director Stanley Kubrick and science fiction writer Arthur C. Clarke of 2001 A Space Odyssey fame. Ripley is a heroine of the film Alien, while Serenity is the name of a 2005 sci-fi film starring George Clooney. Nemo was the captain of the Nautilus submarine in the Jules Verne novel 20,000 Leagues Under the Sea, while Alice is most likely named after the title character in Lewis Carroll's Alice's Adventures in Wonderland. Now that New Horizons has completed its flyby of Pluto, it will be manoeuvred for a flyby of at least one more Kuiper Belt object and 2014 MU 69 has been chosen as a possible first target. New Horizons is expected to encounter 2014 MU-69 on the 1st of January 2019, when it is over 4 billion miles from the Sun. 2014 MU-69 was discovered on the 26th of June 2014 by the Hubble Space Telescope during a survey to find a suitable Kuiper Belt object for the New Horizons probe to fly by. 2014 MU-69 travels around the Sun in a period of 293.4 years in an orbital path inclined by 2.4 degrees, which is very similar to that of the planet Saturn. At the present time, it is very faint, magnitude 26.5, and it lies in the constellation of Sagittarius close to Lambda Sagittarii. It will next be at perihelion on the 31st of March 2068, when it will be 3.9 billion miles from the Sun. The spacecraft will end its mission in 2026 when its power supply runs low. By that time, New Horizons will have reached the heliosphere, just as the two NASA craft Voyager 1 and 2 did so before. About 30 years from now, with its fuel and power exhausted, New Horizons will enter interstellar space and travel quietly to the stars beyond. Pluto is now revealing his secrets, and all of the images and science information from New Horizons will keep scientists busy for years to come. Pluto remains a mysterious cold world which has been brought out of the darkness by New Horizons on this truly historic occasion. That is all we have time for this month. Please visit our website, Vimeo, where you can watch all of the past shows of astronomy and space. And if you like this program, please share it with your friends and members of your local astronomical society. Until we come back next month, goodbye and thank you for watching.